Today we are solving equations, but these are called literal equations. And so that just means we're going to have some equations with a bunch of different variables in them. These equations are real-life applicable equations, and we're going to be solving them for various variables. So it's going to look a little different than the equations we've solved in the past because, for example, when you look at number 1, you don't just see an x in the problem. You know, you see a b, you see a c, and we're going to solve for whatever letter they indicate. Okay, so it's going to look a little weird, but all the rules that we've learned in the past still apply today. Okay, if I want to solve for c, I am going to circle everything smushed with my c. The rule of whatever is outside the circle, you add or subtract, that rule still applies. So if I want to get rid of a positive 5b, I have to subtract 5b. And I have to do this from both sides. 5b minus 5b is 0, so that's gone. Bring down the 12c, bring down the equals. Now, the thing is, I can't actually subtract these. Most of the time, you know, when I'm just solving an equation for x, I can subtract these. These I cannot subtract. So I am just going to recopy this. But I'm going to get in a habit of recopying the variable first and then the constant. So see how this says minus 5b? So I'm going to write down minus 5b. And then this is a positive 9, so I'm going to write plus 9. And then to get c by itself, I need to move the 12. I undo multiplication with dividing, so I'm going to divide this side by 12, so I divide this side by 12. 12 divided by 12 is 1, so all I'm left with is c equals, and I'm just going to recopy this side for right now, negative 5b plus 9 all over 12. Now what this really means is negative 5b over 12 plus 9 over 12. So I can write it in pieces if I want, which would be negative 5b over 12 plus 9 over 12. Now I can actually reduce this 9 over 12, and if I reduce this 9 over 12, what would I get? What can you divide both of these by? You can divide both of them by 3, and if I divide both of those numbers by 3, what would I get? 3/4. So I'd have c equals negative 5b over 12 plus 3/4. And there's my answer completely simplified. I can't reduce the negative 5 over 12, so that's why that still looks that way. So we're going to get answers, and we're still going to have variables in the problem. So it's a little different than before, but all the rules still apply. You know, I circle everything smushed with the c. Whatever's outside the circle, I add or subtract. I still get rid of multiplication by dividing. So it's all the same rules. Okay, number 2. The area formula for a rectangle is area equals base times height. I want to solve for h. So let me circle everything smushed with my h. I look on the side of the equals where my circle is. Is anything outside of the circle? Nope. So that means I don't add or subtract. So I go straight to getting rid of the b by either multiplying or dividing. So I get rid of multiplication by dividing. So I'm going to divide both sides by b. b divided by b is 1. So all I'm left with is 1h or h. And then I can't actually divide a by b, so it just stays a divided by b. And that's my answer. Done. I think it's actually easier than solving our normal equations because you actually don't have to do the division. Up here, I didn't actually have to subtract these. I just recopied. Number 3. The volume formula for a pyramid is V equals 1/3 area of the base times height. Solve for capital B, which stands for area of the base. So I'm going to circle everything smushed with my capital B, because that's what I'm trying to solve for. Is there anything outside my circle? Nope. So I don't add or subtract. So I need to get rid of the h, and I need to get rid of the 1/3. Let's just get rid of the h real quick. How do I undo multiplication? I divide. So I'm going to divide both sides by h. H divided by h is 1. The 1/3 b, capital B, comes down. The equals comes down. I can't actually divide the v by the h, so I just recopy v divided by h. Now I'm still trying to get capital B by itself, so how can I get rid of that pesky little fraction? Multiply by the reciprocal. And what's the reciprocal? 3 over 1. So I'm going to multiply both sides by 3 over 1. Over here, I get 3 over 3, which is just 1. Capital B is by itself. Over here, if I multiply straight across, 3 times V is 3V over 1 times H is H. And there is my answer for capital B. What do you think so far? All right, number 4. This says, write the point-slope form of a line if you're given the point DE and you're given the slope M. So I know anytime I'm given a point, I will start with point-slope form. Y minus y1 equals M times x minus x1. And since they gave me the point and they gave me the slope, I'm ready to go. So I go y minus, this one's the y coordinate, so which of these is the y coordinate? E is the y coordinate. So it's y minus E equals, it wants the slope, and what does it say the slope is? This is my slope, which they say is capital M. In parentheses, it's always x minus. This one's the x coordinate, so which of these is the x coordinate? The D. So I'm going to put a capital D here. And this is the point slope form. So I'm going to stop right there. Kind of ugly looking, but that's it. All right, number 5 says use the point slope form from number 4. Okay, so using this up here, rewrite in slope intercept form. Remember slope intercept form is y equals mx plus b? So I'm going to try to get y all by its little lonesome. Okay, I'm going to just bring this equation down and I'm going to recopy it. And I'm going to work on making it look like slope intercept form. Okay, remember if you ever have parentheses, you have to get rid of those first by distributing. So capital M times x would be capital MX. Capital M times a negative d would be a negative MD. I just bring down the y minus e. Okay, I still don't have y by itself yet, so if I want y by itself, how do I get rid of this little minus e? I add e. So I add e to both sides. I really don't know where to write it because none of these are like terms, so I'm just going to write it somewhere. Negative e plus e is 0. Bring down the y, bring down the equals. Since none of these are like terms, I can't add any of them, so I recopy. I recopy the mx, I recopy the minus md, and I recopy the plus e. And there's my equation in slope-intercept form. Pretty, right? Smiley face. Okay, let's flip our paper over. This says use a formula from your formula chart, fill in the appropriate information, and solve for the indicated variable. Okay, number 6 says find the length of the base of a triangle if the area of the triangle is 82 centimeters squared and the height is 4 centimeters. Okay, so we're talking about area of a triangle. So I grabbed our formula chart, and you can see area of a triangle is 1/2 base times height. So I'm going to write that formula down. Area equals 1/2 base times height. And now I'm going to just start plugging in things I know. So I'm told the area is 82 centimeters squared. So I'm going to put an 82 where the A is, because that's the area. 1/2 just always stays a 1/2. Okay, I'm trying to figure out the length of the base. So since I don't know B, I don't know the base. That's just going to stay a B. And then here I'm told the height is 4. So where the H is, I'm going to put in a 4. Okay, so since I'm trying to find the length of the base, I'm going to circle everything smushed with my B. And then I'd add or subtract whatever's outside the circle. Since nothing's outside the circle, I'm not going to add or subtract. Now, I actually can clean this up a little bit. Since all of these are smushed together, I can multiply. So I can multiply the 1 and the 1/2 and the 4. What do you get if you multiply 1/2 times 4? Reduce. You get 2. So this is simply 2b equals, recopy the 82. Now if I want to get b by itself, how does the little 2 go away? Divide. So I divide both sides by 2, and 82 divided by 2 makes 41. So the base is 41 centimeters. And that's how it's done. Okay, number 7. Says find the radius of a cylinder if the lateral surface area is 36 pi centimeters squared and the height of the cylinder is 3 centimeters. Okay, I am talking about lateral surface area of a cylinder. So let me grab the formula chart. Here's surface area, cylinder, lateral. So this is the formula I want. S equals 2 pi RH. Okay, so S equals 2 pi RH. And I'm going to start plugging in things I know. I'm told that the lateral surface area is 36 pi centimeters squared. So where the S is, I'm going to put in 36 pi. The 2 just stays at 2. The pi just stays at pi. Okay, I'm told that the height is 3, so I'm going to put a 3 where the H is. And they're asking me to find the radius. So radius is what I don't know, so it's just going to stay in R. So when I look at this right-hand side, I can actually do a little work here before I do anything else. Since this is all smushed together, I can multiply, and I can actually multiply the 2 and the 3. How much is 2 times 3? 6. So I have 6, recopy the pi r, recopy on this side the 36 pi. If I'm trying to solve for r, let me just circle everything smushed with it. Is anything outside my circle? Nope. So I don't add, I don't subtract. Now I'm ready to get rid of the 6 and the pi by either multiplying or dividing. How do we undo multiplication? We divide. So I'm going to divide both sides. I actually can divide by both things at the same time. So I'm going to divide by 6 pi to both sides. 6 divided by 6 is 1. Pi divided by pi is 1. All I'm left with is r. On this side, pi divided by pi is 1. And 36 divided by 6 makes 6. So the radius is 6 centimeters. And there it is. Not too bad. Take your time, do a little reading, have some fun. Thank you.